In this work, we use orbital angular momentum, OAM, carrying sound waves to build an acoustic spanner. An acoustic spanner allows to exert OAM on objects, causing them to rotate. We show how to build a free space acoustic spanner based on a 3D printed sound guiding structure and common electrical components. In addition to linear momentum, both light and sound can carry orbital angular momentum. Whereas linear momentum allows one to push objects along the direction of propagation, OAM can be used to rotate them. This form of momentum is different from the perhaps more familiar spin angular momentum. This gives rise to the phenomenon of polarization, and it can be visualized in the case of light as each photon spinning on itself. When an OAM carrying field interacts with an object, it exerts a force both along the direction of propagation and around it. It's like the sort of force that is required to open a door by both turning the doorknob and by pushing the door. Acoustic OAM is generated by controlling the phase of each of the 8 speakers going from 0 to 2 pi. As a consequence, the spatially structured sound field forms a spiral of constant phases. This spiral can be interpreted as a map of pressure which causes the object to spin. It is possible to change the handedness of the OAM and consequently invert the sense of rotation. When the phase differences between the speakers are removed, the produced sound field is of uniform phase and the object remains stationary. Seeing this phenomenon in action is an excellent opportunity to think about the exchange of energy between sound waves and matter, and it is hence an important pedagogical tool. Earlier this month, with the help from colleagues from Wits University, we took our DIY acoustic spanner to an outreach event in Randfontein Primary School, located in a township of Johannesburg in South Africa. 180 students had the opportunity to learn by doing, feeling the effects of acoustic OAM and having fun.